Transformations of linear functions. So first off, we have something called a linear parent function. So what a parent function is a parent function is the simplest function of a family that preserves the shape of that entire family. So for example, linear functions. Every function that is a line is a linear function. However, the linear parent function is the simplest version of that, which is this one here. F of x is equal to x. And remember that f of x is simply y. So y equals x is the parent function for all linear functions. So the slope of the parent function is a 1, and the y-intercept is at the origin at 0, 0, which is why this is the simplest linear function out there. And so the graph looks like this to the right. So it has a y-intercept of 0, 0 and a slope of 1 over 1. Now, we can do some what we call transformations of linear functions. So any other line is a transformation of this parent function. And so these are the three things that can happen to a line. So the first thing that can happen is a reflection. And so a reflection flips the graph across an axis. And so the way we write that is y equals negative f of x. So the new function, the new one, is equal to negative of the entire function of the parent. And so when this happens, when there's a negative on the outside, what that happens is the line is reflected across the x-axis. So this is the parent function, and this is the transformed one. So basically what happened is this piece got flipped down here, and this piece got flipped up across the x-axis here. So if I were to put a mirror on this axis, I would get the red off of the blue one. Now, basically what this means is you make the slope negative. So y equals negative x, y equals negative 2x, y equals negative 1/2 x. Each one of those is an example of a reflection from the parent function. We can also change the slope. So by changing the slope, what we do is we multiply f of x by a constant. So we take f of x and multiply the outside by a number, and we're going to call that number a. So if the number that we multiply is greater than 1, we come up with a steeper line than the parent function. So if we try to imagine walking along the blue line, which is the parent, and the red one, which is the new one, I would say that the red one is steeper than the blue one because it has a greater slope. The parent function is a slope of 1, and if I multiply 1 by a number that is larger than 1, I get something greater. Now, if I multiply the slope by something that is smaller than 1, but not less than 0, because remember, negatives is the reflection piece. So if I multiply by maybe 1/2, well, this results in a line that is less steep. And so if I look at what I've got, here's my parent function, and then if I were to walk on this red one, it would be a little bit of an easier walk because the slope is less. It's a smaller slope than the parent, so it's less steep. And then the last thing that can happen is a translation. So a translation shifts the graph of a function vertically, up or down. And we represent that by adding or subtracting a number to the outside of our function. So if we add a number, that means this line is shifted up by whatever number we're adding. So it used to be at 0, 0, and this got shifted upwards to this new y-intercept. If you do minus a number on the outside, the line is shifted down by that number. And so if I start at my parent, the new line got shifted down. And we look at the y-intercept, not the x-intercept. Because if we look at a linear function, it is a slope and a y-intercept that is important. So let's put all this together in one gigantic representation. And so we're going to label some things. So let's start first with this a value. So I'm going to write some of that over here. So if it is a negative a, it was reflected over the x-axis. If it is a negative a, it's reflected over the x-axis. Now, the a value itself, if a is greater than 1, that means you have a steeper slope. I have a greater slope than my parent. If my a is between 0 and 1, because remember, the negative has its own job. The negative does the reflection. So a half and a negative half are both less steep. you represent a less steep slope. So that's what A controls. A controls your slope. And then at the end, we have plus or minus a number. So we have this plus D. And so if I do plus something, what that does is it shifts the line up by whatever D is. And then if I have minus a number, that will shift the line down by whatever D is. And so A affects the slope, D affects the y-intercept. Maybe we can write that somewhere as well. I'll write it in orange. So this guy affects the y-intercept, and A affects slope. Okay, this is something good to memorize because when we hit functions later on down the road, we're going to come back to this and just add more pieces to it. Let's look at some practice problems. So for example 1, determine the effects on the graph of the parent function f of x equals x when g of x is equal to f of x plus 4. So we can do this a couple ways. So first, this is the original. That's the original function. And so we can use substitution to help us out, or we can use that graphic up above. So if we want to use substitution, I see that here is f of x, and here's f of x is equal to x. So I know that x and f of x are interchangeable throughout this entire problem. And so what I can do is I can interchange. So my new function, g of x, will equal to basically my old function, x plus 4. And I'm going to put that in parentheses. My old function, x plus 4. Now I don't really need the parentheses this time because it's just an x. So g of x is equal to x plus 4. And if I compare this equation to this equation, I can see their slopes are the same. Their slopes are 1s. And the y-intercept is now a 4 when it used to be a 0. So what happened to my graph? So having a y-intercept of 0 here and then having a y-intercept of 4 means my graph was shifted up 4 units. That is the transformation that happened from F to G. Now, there's another way you could do this. There's another way. You could recognize that this plus 4 is the D. That's that D value from earlier. That's this piece here from just a minute ago. And I know that if I have a plus number on the outside, my line will shift up by that number. And so since this is plus 4, that means my line will shift up 4 units. Either way is acceptable. Pause the video, try number 2. And here's what you should have had for example 2. So I know that f of x equals to x, so everywhere that I see an f of x, I can exchange that with just x. And so when g of x is equal to 2 times f, I can replace this f of x with x and then simplify. So my g of x is actually 2x. And so I'm going to compare the graph of 2x to the graph of x. And I see that originally I had a slope of 1, and now I have a slope of 2. So since 2 is greater than 1, that means my g is going to be steeper than the original f. That's one way to complete this. The other way you could have completed this is by noticing that 2 is actually the a value. And if you had an a greater than 1, that meant your slope was steeper. And so because 2 is greater than 1, that creates a steeper slope. Either way is fine. If you look at example 3, determine the effects on the graph of the parent function f of x equals x when g of x is equal to negative 1/3 f of x. And so again, I notice that f of x and x are equivalent, so I can replace them as I need. And so g of x will equal to negative 1/3 times f of x, which I'm going to replace this with x, because that's what they are equal. And then I can simplify by basically getting rid of the parentheses. So what I have is my new function, g of x, is equal to negative 1/3 x. And now I'm going to compare. So I see that this slope is a 1 and this is a negative 1/3. Well, there's actually two things going on here. This slope is positive and this slope is negative. So what happens when you change the sign of slopes is you actually create a reflection. So the graph of g was reflected over the x-axis. That's the negative piece. Going from a positive slope to a negative slope is a reflection over the x-axis. Now, also, I can see that it went from a slope of 1 to a slope of a third. We took care of the negative already, so I'm going to kind of ignore that. So going from a slope of 1 to a slope of 1/3 is a smaller slope, which also makes the graph less steep. So not only was the graph reflected over the x-axis, it also became less steep than the original f of x. So there were actually two transformations here. And if you wanted to solve this with the method number 2, is I recognize that this here is again the a value. And remember, a has two jobs. Since it is a negative a, that's where the reflection comes from. And because 1/3 is smaller than 1, that's where the less steep comes from. So you could have either done this in one of these two ways. Let's look at example 4 together. So determine the effect of the graph of the linear function f of x equals 2x minus 1 when h of x is equal to f of x minus 2. So if you notice, this is now the original function, and this is not the parent, and that's okay. So this is the original this time, and h of x is my new one. So what we're going to do is, again, I'm going to replace f of x with what it is equal to. So this here is going to be replaced with all of this, because that is what f of x is the same as. And so my new function, h of x, will equal, I'm going to put a parenthesis because I'm substituting, f of x gets replaced with 2x minus 1, and then I still have minus 2 hanging out on the outside. So now I'm going to simplify this, and so there's no number in the front, which means I'm not going to multiply anything. So I can go ahead and just drop my parentheses. So 2x minus 1 minus 2, and I know that I can add those two things together because those two things are like terms, and so I get 2x minus 3. And now I'm going to compare. So I'm going to compare f of x to h of x. So what I notice is this. This guy had a slope of 2, and my new slope is still a 2. So since this number did not change, there was no change in slope. So the steepness is the same. However, I do notice that this y-intercept was a -1, and now my y-intercept is a -3. So the graph was shifted down. And how many was it shifted down? Well, if I went from a -1 to a -3, well, that means it had to be shifted down 2 units. And that's the only transformation that occurred. And if you wanted to do this in another method, I could see that, oh, I know that a number out at the end is my d parameter, my d value. And if it's a minus, that means it'll be shifted down. And so that's how you could have also gotten to the correct answer. Let's look at number 5, and then you'll try number 6 on your own. So number 5, determine the effects of the graph of the linear function f of x equals -2x minus 3 when k of x is equal to 1/2 f of x. Okay, so let's look. This is the original, and my new function is k of x. So let's see what I can maybe do. So k of x is equal to, so here we go. So I know that f of x can be replaced with everything here. F of x can be replaced with -2x minus 3. But I have a half out in the front, so I'm going to have to do 1/2 times, because that's what this is doing. 1/2 and f of x are multiplying together. Then my f of x can be replaced with -2x minus 3. And that's it, because there's nothing added or subtracted here this time. And so when we simplify this example, we're going to actually distribute in that 1/2. So our new function is k of x equals 1/2 times -2 is -1x, and 1/2 times -3 is -3/2. So now that I have this simplified, I can compare my new function to my old function. And I'm going to look at their slopes. So first I see that the original slope was negative, and so is the k of x, the new function. And so since there was no change in sign, that means there wasn't a reflection. If this had been negative and this had been positive, it would have been reflected over the x-axis. But since they're the same sign, there is no reflection. Now let's look at the value of a itself. Let's look at the slope. So 2 and a 1. So I went from a number at 2 down to a smaller number. So what that means is that this new line actually became less steep. I originally started at a slope of 2 and now I'm at a slope of 1. Then let's finally look at the y-intercept. I see that this is -3 and this is -3/2. So what happened is -3 and -3/2, I actually went up because -3 is smaller than -3/2. So that means I got closer to 0. So I actually was shifted up. So we have to be careful when we use function notation. So if this is not the parent, this function notation method doesn't work all the time. So we have to make sure we plug in to make sure we're getting all of the transformations when it's not the parent function. If this is the parent, then I can easily use the function notation to get the correct answer. Pause the video, try example 6. And here's what you should have had for example 6. So f of x gets replaced with 7x plus 5, with a negative being multiplied to the outside and a 4 subtracted on the right. So distribute out the -1, combine like terms after, and you end up with -7x minus 9. So the slope went from a +7 to a -7. So from a positive number to a negative number means there was a reflection over the x-axis. Now it went from a 7 to a 7. So the value of the slope didn't change. And so that means the steepness is the same on both of these. It's just one is going up and one is going down, which is where the reflection comes in. And then finally, I had a y-intercept at 5, and now I have a y-intercept at -9. So my transformation is actually a shift down of 14 units. Going from a y value of 5 to a y-intercept of -9 is shifting down 14 units. So one more time, if this is not the parent function on the original, you have to be careful with function notation because this says only down 4, but you actually moved 14. If it's the parent function, then I can use this function notation very easily. Let's look at some graphs. So number 7, describe the transformations that took the linear parent function to g of x shown in the graph below. So f of x is the parent even though it didn't quite say it. So since I'm taking the parent to g of x, I know that this guy is my new one. So I like to maybe look at the y-intercept first. So my original y-intercept is at 0, and then I had to move down to get to my new y-intercept. So one transformation that occurred was that g of x was shifted down 3. That's one thing that happened. Now let's look at our steepness. So if you would like to actually find the value of slope, that is one way to do this. I know that this guy has a slope of 1. That's just what the parent function is. Now for the red line, I can see that this red line is a little less steep. It looks flatter. It looks more flat. And so my red line is less steep than the blue line. So these were the two transformations that occurred. If you would like, pick 2 points. Here's 1 point, here's another point, and find your slope. So we've got y2 minus y1 over x2 minus x1, and you end up with -1 over -2, which is 1/2. So what happened is I went from a slope of 1 to a slope of 1/2, which created a less steep slope because my slope got smaller. Now let's look at number 8. So for number 8, describe the transformations that took the parent function to g of x in the graph below. So again, I like to start at the y-intercept. So I see that this y-intercept is at 0, 0, and then it moves up 1 unit to get to my new graph. So the first thing that happened was it was shifted up 1. And then let's look at our slopes. So the first thing that I notice is this is moving upwards and this is moving down. So the first thing that had to happen was it had to be reflected over the x-axis. So I've got 2 transformations so far, shifted 1 up and reflected over the x-axis. And the last thing I need to tell is steepness. Now this one's not as clear as example 7. I know that my blue line, my parent function, has an m of 1. So let's find the slope of my red line. So this coordinate is at 0, 1, and let's pick maybe this coordinate at 1, negative 1. And I'm going to actually find my slope. So y2 minus y1 over x2 of 0 minus 1. So I have negative 2 over negative 1. So let's actually find the slope. So I have y2, which is negative 1, minus y1, which is a positive 1, over x2, which is 1, minus x1, which is 0. And so I end up with negative 2 over 1, which makes negative 2. So my slope went from a positive 1 to a negative 2. We already did the sign change. Positive to negative is the reflection piece. Now going from a 1 to a 2 means my line actually got steeper. So there were actually 3 transformations on this one function. Pause the video, try examples 9 and 10. And here's your solution. And so we're actually going from f of x, this is the original. I know it says parent, and that is not correct. It's not the parent function, but it is the original. Same thing on number 10. It says parent, but f of x is the original. And so for number 9, if you look at your y-intercept, you started at 1 and got to a negative 3, so that was shifted down 4. And this red line is less steep than the blue line, so that was a change in slope. For number 10, I started the blue line and go to the red one, and that was shifting up 3, and the red slope is steeper than the blue one.